Sir, it was okay, but then actually I wasn't aware of the chemistry syllabus. Like I
Mm-hmm.
didn't know that electronic effects. I thought only this thing was coming. Hyperconjugate. Sorry, inductive effect.
Mm-hmm.
So I didn't bother reading the other stuff. I
When you say other
many
stuff, can
questions.
we be a little bit more specific?
Yeah, the other like this hyperconjugation and I mean hyperconjugation I was able to do, but then there were questions about mesomeric effect those-
Mm-hmm. Okay.
and they were mainly based on the order of the things. I didn't read that.
Okay. So basically, they were direct, easy, but data-based questions.
Yeah, yes.
So effectively, you are using your vast intellect here to come up with meager excuses as to why you did not score in an exam where everybody else scored.
Others also felt the same way.
Okay.
We no one knew that this was coming actually.
So the entire class got scuttled then.
Yeah, kind of.
That's good, nah. In that case, what was your score? How did you
So
rank when everyone was scuttled?
sir,
That's very useful data.
in my class, I think it was someone top 10, I guess.
Chemistry liya illa total?
Oh, total.
What the fuck? That I already know you are there. Chemistry I'm asking in this organic part here.
Sir, but top 10 in my class is like 100 overall.
What?
It was online.
Repeat again, 100 overall? No, I do not understand.
I mean, like many people cheated. That's why rank will go very high.
Oh, so lots of kids effectively did
Yep.
go wrong and
Yes, sir.
had fun exploring their creativity.
Yeah.
Right, fair enough. Okay, so how did you find the paper then? Let's forget about the results. How did you find the paper?
So it was pretty easy actually. But
And how much did you score out of how much?
sir, I fit the total. It was pretty bad. Out of 90, I think 55 or something.
Okay, this is the chemistry part, I suppose.
Yes, sir.
Okay, and all put together,
301 out of
that's a good
390.
score. That's not a bad score at all. That's a good score. So you did very well in the overall bits exam format then. Yeah,
Yeah,
language would have been
kind of.
something which you could have kicked ass anyway. So yeah,
No, language I got.
That's the point I'm trying to say there. You would have definitely got the language more.
Oh, yeah, yeah.
Others would have
Sir,
definitely.
actually,
Huh?
this math and, sorry, not math, this English and aptitude, it was the exact same paper as they gave last time. But
Okay. Yeah.
yet other people couldn't score full.
See, what did I tell you about your performance in organic chemistry?
It won't be that good for now until you
Why did I tell you
like
that?
reach that.
Why did I tell you that?
Sir?
Why did I tell you that?
So you won't compare.
Yes. Why did I tell you not to compare?
It won't serve me any good. I mean,
So when I
yeah.
say it won't serve you any good from your point of view, when it comes to a weakness of yours and when it comes to a strength of the others, the same thing applies when you look at it from the other angle as well. Intellect is your strength. Don't look down on others just because you are more intelligent than them. It will come back to bite you badly because the version of you now is definitely more intelligent than the version of you a few minutes back or a few days back. So there will come a time when you start looking down upon your own self. It's a very weird cycle to go down into. Avoid unnecessarily stoking up your ego by these small actions because that's literally what you just did. It's not necessary for someone like you. The higher your intellect, the more you will need to prove to yourself to satisfy your own goddamn intellect and your ego. See, fact is, you will not be happy if you do not make it into top 500 in IIT. Your parents will be satisfied with you being in top 2500, top 3000. But for your own fucking ego, you will not be happy if you don't get into top 500. My ego was so high in my year, which was like ages ago, that I basically decided to myself, if I did not get within top 1,000, I would not take up IIT. And it just so worked out that my rank was some 2,400 something. And what to say, I had full scholarship and free right to go to a foreign country and study, to Singapore and study. So yeah, I was very lucky that I had a scholarship and everything else. But my ego did take a beating. And what to say, fact is, I didn't utilize the resources provided to me. I was too childish. I didn't give a shit. I prepared barely for like last like 2 months or 3 months, maybe maximum. Uh, Mine was very different. Competition was nothing at that time as well compared to what you kids face now. So absolutely not fair to compare anything there. But that's the point I was trying to make. Both are different yardsticks. When I tell you you should not be comparing with them in their yardstick, it also applies in the reverse. You should not be comparing with them in your yardstick. If you can't even defeat them in your goddamn yardstick, what the fuck are you doing? Where are you putting your ego? Think. See, you should not be clashing in intellect with in that kind of a scenario. Your strength is intellect, but that also means you have to understand that there are weaknesses to intellect. You will come up with unnecessarily faster conclusions. You will assign unnecessary efficiency parameters regarding things, which sometimes turn out erroneous as well. Anyway, coming back to the discussion. So yeah, how did you find the what to say bit style paper in chemistry in terms of the topics which you have already learned?
Like the previous paper you're asking what, or like
Whichever papers you have written so
uh,
far now, I think you have written two papers till now, no?
two papers, yes, sir. Yeah.
So how have they been?
They've been okay, sir. I mean, this time
Explain.
maths was like last exam it was very easy, like much easier than this time. But
Mhm.
this time the problem was math was a bit lengthy again. So it took like a
That's the
decent amount of time.
expectation, isn't it? Max is supposed to be 1 hour 15 minutes.
Yeah, it took 1 or 15 minutes. Yeah,
Uh,
exactly.
it's supposed to be 1 hour 10 minutes to 1 hour 15 minutes. That's not really unexpected.
Yeah, but like I didn't like last which exam it was very easy, like 45
Yeah,
minutes.
I
Like
understand that. That is not something
yeah,
which I am interested in listening to. I am looking at how you performed in an exam which was the right length of a proper JE mains style paper or even a JE advanced style paper. Max is going to be the lengthy one in both the JE mains and the JE advanced usually. JE advanced sometimes physics is also lengthier, but JE mains for damn sure it will be Max which is lengthy. So when I
hmm,
say lengthy, I mean it is going to be a typical paper which will take a good student 1 hour 5 minutes to 1 hour 10 minutes. And
hmm,
uh, judging you on that scale as well, 1 hour 15 minutes at this stage of your preparation sounds about right for a good paper, a standard paper, not a tough paper, not an easy paper, but one where they probably made you and forced you kids to solve two stages for each question, or at least for 10 or
okay.
15 questions, two stages of questions were there. So
Yeah.
that is going to be the typical max paper. So what went on? Tell me how it went. So it's a very good sample set for you to analyze what your results have been.
Hmm. Yeah.
What was your performance like? Give me your max score, give me your physics score, give me your chemistry scores.
So math, out of 120, it was 104, I guess, and
Okay.
then 104, 105, I guess. Yeah,
Mm.
and then physics out of 90, it was pretty low. It was 63.
Not bad. Mm.
And then
Chemistry was 55 something, right?
yes, sir. Yeah,
Okay. All right. And how did this add up to 301?
sir. English and IQ.
Okay. Huh. Mm. Okay. All right. Okay. Okay. And okay. How about the other paper you wrote? You said you wrote two papers, correct?
This like the other paper was back then a while ago.
What was the scores in that?
It was 322. I guess
Out of
390.
Same bits paper as that also.
Yes, sir. Yeah.
You wrote two papers bit style recently.
No, no, not recently. This was a while back.
Okay. Let me rephrase what I was asking for. What happened with your previous exam in organic chemistry other than this bit style exam?
Oh, sir, I think we discussed that already last week.
Okay, so we already discussed that.
Yeah.
There was one advanced style paper we discussed and one main style paper we discussed.
Huh.
And there should have been a third paper, is what I remember. The third is not there. Instead, there is a bits paper.
Yeah. Yes. Yes.
And the fourth was supposed to be the bits. So 1 week in the middle, you guys did not have an exam in the last 3 or 4 weeks.
Yeah. 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 1 week. I think the first week was second week. Yeah.
Okay, all right, take it. Okay, so let's continue on. Where did we leave off, and what are your issues in the current bunch, and how much have they covered so far?
Sir, we have done till. I mean, we're still discussing resonance.
Mhm.
Like, I think resonance is a pretty big
Yes,
thing,
it
but like, yeah, we were discussing. So we like straight about we did since we started organic chemistry. Did you see that?
Sorry.
Should I tell what we covered since we started general organic chemistry?
Yeah, sure.
Okay.
Wherever you have
Huh.
issues in, highlight those parts so that I can basically directly go into that.
Uh,
Hmm.
not. One second. Sir, I actually had a few doubts from.
Yeah, go ahead. We'll start with that itself directly. Hmm. You sending me the doubts or what's?
Yes, sir. I'm sending it. Just a minute. Hmm. One second.
Give me a second. Let me get my phone.
Okay, sir.
Bye, Wendy. Good. Have you sent me the question or not yet?
One second, sir. I'm sending it. Sorry. I'm not able to find the other question.
Okay, just tell. Oh, you found a question already. Okay.
I sent one of them. Sir,
Hmm.
I had a
Yes.
doubt. Why is the first one not chiral?
As in your question in this particular question here is, why is the first molecule not chiral?
Yes, sir.
Okay, all right. Okay, so here's the deal. Let's talk about this thing quickly here. So this guy, this carbon here, this side and this side are same. So not
Yeah.
chiral. This molecule here, I have a plane of symmetry here, so not
Yes.
chiral. When it comes to molecules involving cyclohexane, when you have to consider it from the point of view of geometrical or from the point of view of optical isomerism. The best way of going for that is to learn how to interconvert between the structures. When I say interconvert between the structures, pretty much what I taught you earlier, how to convert the chair into planar or the planar into chair or say half chair, whatever it is. Interconvert between them. Why interconverting is useful is because when it comes to checking for optical activity, the best structure to check is in the planar form. Because in the planar form, you can directly see what is going to be the plane of symmetry, etc., without really complicating shit beyond a point.
Sir, but then if it exists at chair, then it doesn't have
It
a.
exists in the chair also. I'm saying it is easier to see in planar. I never
But
said it
then,
doesn't exist in chair. Listen to what I said carefully. I never said it doesn't exist in chair. I'm saying switch it into the planar to see it more clearly in your brain. You
sir,
remember
but then,
what I discussed with you a while back about how you are probably the type of kid who did not solve the Rubik's Cube by yourself in the first place. This is something which applies in that direction. You are not the kind of person who is going to be, the way I understand you is, you will not be spatially inclined to the best extent possible. Your hand and leg coordinations are probably not going to be that good. You're not that good a batsman, maybe. Or are you a very good batsman in cricket?
I don't play cricket much.
That basically means you suck at it. That's pretty much why you don't go near it. So, people are what they are. I'm guessing you play to your advantages and try to play a little bit of basketball or nothing else.
Basketball. Yeah.
Hmm. Nothing much else. And basketball also, you are like the lanky guy who likes to stand in a corner and play.
Uh, Not that much, no.
You also you're an active fellow, is it?
Yeah.
Oh, not bad. That's fun then.
Yeah.
That should be interesting. I misjudged you very wrongly there then.
Mm.
But still, the point here is effectively that in this particular case here, it is easier to check in the planar form rather than to check in the chair form. I'm not saying you should not check in the chair form. Check in the planar, find out what it is, then see how that translates into chair or boat or whatever. The idea here is you basically have to start making yourself a little bit more flexible with respect to the thinking of an organic molecule. You cannot think of it being a rigid species. It is going to be constantly changing. And plane of symmetry, what does plane of symmetry mean? You tell me. Or any symmetry element which has to be there for chirality if you're checking. The idea here is the system should be having no plane of symmetry or no way symmetry is possible. No way symmetry should be possible in any of the conformers. Only then is it optically active. So it doesn't matter which conformer you take. You can bend
Oh,
it
okay.
as you wish, check it out, then non-bend it, no problem. But it should be
Mm.
unbendable. The bending and non-bending should be something which is allowed. It should not have any energy barrier. There should not be any fat fellows who are basically preventing the thing from bending. For instance, if there are going to be two bulky groups, which are basically in equatorial currently, all right, for a structure to basically go from this to something else, one chair form to another chair form, it will have to bend in the opposite direction. It has to become a boat or something of that sort. Now, in
Mm.
that case, there will be extreme repulsions. So in that case, the bending may not happen. That particular thing will have an energy barrier. So
Mm.
energy barrier is something which you'll have to start, paying a little bit more attention to. When it comes to stereoisomers, how was it that I tried to define it for you? I told you there has to be an energy barrier. That is the start. That is the key thing from which exceptions will start. When I say exception, what do I mean by exception? In your question papers, you will have these new interesting questions. Let me put it that way. The ones which you find very tough in the paper now, which are not the obvious standard ones, which your friends who have a little bit more experience with the subject understand that these are trick questions and they need to prepare for them separately. Those are basically going to be directly solvable if you go check from the logical angle every time, a more core logic. So when I say more core logic here, this is the type of thing I was talking about here. So In this particular case here, the easiest methodology is convert it to planar and check. If it is planar, in this case here, it doesn't matter how the CH3 and H are. Same way OH and H are like this, correct? That means if it is a 1,4 type of system, what's the thing there in a 1,4? I will always have some plane like this. All right. If it is a 1,4 system, I will always have some plane like that, meaning the same rules you applied earlier over here apply here also. Why did you not apply them at the same time? Because you did not think to apply them. In the chair form, you basically got tricked in straight away. What I'm trying to tell you here is these two carbons are not chiral, or not even optically active, not chiral carbons.
Oh yeah.
You stupidly ended up assuming shit over there because you got screwed by chair. Now do you see why I told you about the planar here?
Yes, sir. Yeah.
When you're going to be having a more complicated drawn structure, it is something which is very easy to fool the brain. Especially for someone who is an intellectual who believes they are going to be correct based on gut feeling and shit. Your instinct told you something was weird here. Instincts are trainable. You train them the wrong way, they will lead you down the wrong path. So, am I clear?
Yes, sir. Yeah.
You stupidly did not even do the basic check here.
Yeah.
And you are asking me.
I'm back. Yeah.
Fair enough?
Yes, sir. Yeah.
The reason why I was addressing the question this way was because this was your stupid problem. You blinded yourself unnecessarily.
Yeah, yes, sir.
So I had to show you you were blind and then poke you in the eye.
Yeah.
Have I poked you properly?
Yes, sir. Yeah.
So that's why I started with option 4 as well. You can see here that both of these sides are the same. In this also, both of them are the same.
Both are same, yes. Yeah.
This also, both are same. Just because it is going to be something which is a non-planar structure doesn't mean you should get tricked by its unnecessary bullshit tricks.
Yes.
These two are different, and obviously this guy is a chiral molecule.
Yeah. Yes.
Again and again, we come back to your same problems. Unnecessary assumptions. Unnecessary assumptions. Okay?
Yes.
Yeah, you sent me the next one as well.
So I'm not able to find it once again.
So you gotten scared away that much now.
No.
Okay, tell me what
question is there.
Discuss.
Sir?
Tell me what the question is like.
Sir, it was about like which of the following are enantiomers, sir, diastereomers.
What kind of a molecule?
So they gave these like different options. Like, you don't know the options exactly. Sir?
Okay. Large number of options, messed up set of options then.
Oh, yeah, kind of, yeah. I'll search for it. Yeah.
Find it when you find it. Next, what other topics to discuss? What other things to discuss for now?
You said this minus I and plus I order is there, right? How do we exactly like come up with that?
Send me the order which you have been given. We'll talk. You write good notes or you write shitty notes?
I think this is understandable.
So you write very good notes then. Good.
Not too good, but like.
But you scribble off everything which the teacher tells in class.
Yeah. Some of it.
That's what I mean. That's very good notes. The teacher properly copies from the best books. I'm quite impressed actually. Fidji's teachers' levels have increased, man. And I mean that very seriously. I suppose on all top places will have good teachers. There's no escape about that. Yours is one of the top campuses, or it's what campus is it in Fiji? Second or third or fourth?
Well, barring the Siam batch in Madhapur, this is the best.
Second batch then.
Yeah, second best. Yeah.
Nice, nice. And the Madhapur one will be getting like say 4 or 5, maybe 10 also in top 100 consistently, right?
Yeah, not 10, but like I think
4 or 5
5.
consistently.
5, yeah. 4, 5.
Hmm. Same as the standard, huh? Go on, huh? Let's continue on with this. Which ones do you have issues on?
No,
Or
my
should I
general
do
that is,
a general direct thing?
yeah, can you tell that the general thing? How do we exactly like? Is it experimentally or like?
Obviously, it's experimental, but there's obviously going to be reasons also.
Hmm. So, I know about the NR3 and NH3 one though.
First
Like
off,
the
maybe what do you know
bond
about
length
inductive effect?
inductive effect.
Hmm.
Well, it pretty much is when one polarized atom polarizes the other. Like suppose there's an electron negative atom, it pulls the electron density towards it, and then as a result, it pulls all the other ones around it, like nearby ones as well, even the further ones.
Okay,
Like like it polarizes the sigma bond
all of
of
that
all the
is
adjacent.
fine. Explain to me in simplest words and show me that you have understood.
It's pulling.
Show me you have understood doesn't mean I want you to use the same words you have heard. So it's like
It's like greedy, pretty much. Like
not bad, good. That is a good term. I like that one. So effectively,
it's like
when there
tax
is
collector collecting.
when there is something which is more electronegative, what does it mean for something to be more electronegative?
It wants electron density
What
near it.
electrons?
Sigma electrons.
What do you mean by that exactly? The bond pair of electrons, not necessarily
Ah,
sigma also. It can be pi also. So yes, we define it from sigma point of view, but it actually is going to be both. The pi is just a little bit less strongly attracted than the sigma because it is in a different angle, so it is going to be at more distance from the nucleus. So effectively, electronegativity is a tendency of the nucleus of a system to pull or attract any shared pair of electrons towards itself. So by
hmm.
creating that, by doing this, what happens is it is going to be literally creating an imbalance in the what to say
Molecule.
flow of electron density in the system.
Oh, huh.
So this imbalance which it is creating is going to be something which will be cascadingly felt. So if I'm going to be having a molecule like this, if there's a sudden center of greater electron density or electronegativity, let's say this part is more electronegative, this will literally tilt downward. That's the best way to imagine it. So you can think of it as the field or the gravity in that region to which the electrons are attracted towards is literally being bent downward. So
Hmm.
what's happening is anything which is present over here is going to be feeling that effect to a greater extent. And the one which is present over here will feel that to a lesser extent. The one which is present over here will feel it to an even lesser extent.
Yeah.
And the one which is present over here, it doesn't feel it at all. Because by
Yeah.
the time it reaches here, it's flattened out.
Yes.
You understand the idea here? So
Yes.
effectively speaking, the best way to imagine it is imagine the electric field in a way, and the plane of the electric field of the molecule is dipping downwards at the location of greater electronegativity,
Like gravity. Yeah.
in a sense.
Yeah.
So if it is dipping downward, effectively you're going to be having a slope getting created. That slope is going to be most felt by the fellow who is closest.
So yeah.
So what are these groups giving you? These groups are giving you pain centers. How
Imbalance.
much is it dipping over there in that field? How much of a deep dip is it creating? So the depth of the dip is going to be predominantly dependent on the desperation at that location.
Yeah.
You understand the idea here?
Yes, sir.
Okay, so now let's go for the order here. So, which ones do you understand? Which ones do you not understand?
So the FCl, VRI, I understand.
The iodine, bromine, fluorine, fluorine, you understand? Okay.
Yes, and then I think the C triple one CH and the second to third to last one and the second one.
This bunch is easy. Hydrogen is going to be your standard.
Yeah.
Okay. This is going to be an sp2 hybridized carbon.
Yes, that will be SP, so that's why less.
Yes. And then
More
we are going to be
electronegative.
having phenyl, which is sp2, but it is a ring.
So
effectively, there is more sp2 carbons there.
oh, that's
Compared to here, it's a longer chain now, so it can ring up. So sp2 ring. So it is slightly more. NH2.
okay.
This is, pay attention here, this is sp3 nitrogen. So they're
Yeah.
telling you the sp3 nitrogen is more than the sp2 carbon, but less than the sp carbon. Do you see the key thing which you should notice over here? What is the key point you should remember over here? The key point you should remember here is in terms of electronegativity.
Nitrogen is between. sp3 nitrogen is between.
So sp3 nitrogen comes in between the sp
SP
hybridized carbon and
sp2 hybridized.
hybridized carbon. This is something which will be very useful for you in a later dynamic. Now, when I say later dynamic, what do I mean here? I mean something like this. Let's say I am looking at an acid-base type of reaction between NH2 minus and say this hydrogen and say this hydrogen. What will happen is in this first case here, this can react. It will produce an NH3 and it will end up producing this fellow for me. Why will it do this? Because this is
More
a better
electronegative.
acceptor than that guy, than this C minus.
Yeah. Yes.
And this fellow can escape outside as a gas. So when it escapes outside as a gas, you will end up having forward direction happening. Actually, you do not understand that. Or do you understand that? Le Chatelier's principle you have done, is it?
Yes.
Then you understand this then when you are having a precipitation reaction or a gas formation reaction that will be moving in the forward direction. Why? Because the gas is being released, the product is escaping outside. So forward direction will forcibly happen.
Yeah.
This will not happen at all because this is going to be in the opposite direction. So these kind of orders, when you get them, pay very close attention to them. When you pay very close attention to them, you will automatically start being able to, smell inconsistencies in them based on how many times your teacher has to give you the order. Because every order will be connected. If you understand the connections between each order, you can check and verify, has your teacher given you the correct same type of thing or not? Or is there inconsistencies in those orders over there? When you see inconsistencies in those orders, you should be a little bit, accepting that different textbooks sometimes give different data. So give your teacher the benefit of the doubt there as well. Because I can see this order is good. And he has taken a good amount of pain to give this order for sure. And I'm not even kidding. Trust me on that. This is a very well put together order. Not bad at all. And then OH and then OR. So this is going to be, of course, sp3 oxygen. This is also sp3 oxygen.
Yes.
Normally, though, in this particular case here, I would prefer an OH and an OR being reversed slightly. All right. Slight reversal would be better because the R over there is usually going to be a plus I group.
Carbon. Oh,
It's a plus I group. Plus inductive.
sp3 carbon.
So if it is a plus inductive group, it is going to be donating to the oxygen rather than pulling away from the oxygen.
Yeah, that's what I was thinking.
Your teacher here has probably made the small assumption that the carbon is more electronegative than hydrogen. So it should be pulling more from the oxygen. But that is not the way it works. The logic which he probably went with over there is related to that. The carbon is more electronegative than hydrogen, so it should technically pull more. But it is not a carbon, it is an R, it is an alkyl group. Alkyl group's net effect is a plus I compared to a hydrogen. So when you define inductive effect and something as a plus I or a minus I group, what is the standard against which you are measuring it?
Hydrogen.
Hydrogen. So when I say, or when we talk about an alkyl group being a plus I group, an alkyl group is a plus I group means
With
it
respect to hydrogen.
more than hydrogen. Net effect is more donating than hydrogen. You understand the principle there?
Yes, sir. Yeah.
So I would prefer to switch these two, OR and OH. Otherwise, the order is fine till here. Next is COOH and then C double bond O. Now, in this particular case here, why is the order like this? Why is the COOH lesser than the C double bond O?
So maybe, so but it's not mentioned R, right? So
tell me why. They are talking about inductive effect only. So he's giving you that this group as a group is weaker than keto. Why? In the keto here, I will be having this sp2 carbon attached to an sp2 oxygen directly present here, correct?
Yes, sir.
Okay. In the case of the carboxylic acid, what is going to be happening is we will be having this being an sp2 carbon only, and this will be an sp2 oxygen only, but there will be resonance with this bugger. Correct?
Yes.
That means carbon is technically now with an sp2 and sp3 in between oxygen.
Okay.
That is probably the argument with which your teacher has given that. But I will still not agree with this. I do not know about the data behind this here. I have another conflicting logic also associated with that. So I would not go with this particular part of the order with this much surety. You will not be getting that many questions comparing those. Avoid that game there. My gut feeling tells me that is not perfectly correct. That is another assumption which your teacher has probably made based on some questions he has seen. Now, let me give you a conflicting argument for the same thing. This carbon is going to be something which is going to be always having sp2 hybridization, definitely. Correct? Whether there is resonance or no resonance, it is an sp2 hybrid.
Correct. Yeah.
Same way, whether there is resonance or no resonance, it is always attached to an sp2 oxygen.
Yeah, that's what I said. Yeah.
And compared to this fellow, which is going to be mostly an alkyl, this is definitely electron withdrawing.
Yeah.
Right? So
but you don't know it's alkyl, right?
Yes, that's R means alkyl, no?
No, but it's not.
There's nothing there. Nothing means it's a alkyl, no?
Okay,
Keto,
okay, that's what I was thinking.
So I can still argue in this fashion here that there is going to be no effect over there, or the effect is going to be opposite. Are you trying to see what I'm trying to explain to you here? Never
Yes.
ever bank on data which is half cooked. Recognize sometimes that this is half cooked and why it is half cooked. In this case here, all these three are very tricky business. Do not compare them here. Do not add them. Club all of them together. Think of all of them as very similar to each other, but do not think of this being better than that in your brain. Aldehyde, keto, carboxylic acid are all similar. No more, no less. Because if you start associating unnecessary orders there will be places where it will go this way or that way. The reason why the order has been given this way is mostly because your teacher has seen more cases on the one direction in which he's basically given the cases. But these three are very close by in terms of their effects over there. I would not recommend memorizing any particular order among those three. I have seen, like, for some cases, the aldehyde being worse off than the ketone. Sometimes I have seen the ketone being, as he has mentioned over here, better off than the carboxylic acid. But usually, carboxylic acid will be better off than the ketone. I have seen those also. So avoid memorizing any specific order among those three there. I hope you understand what is the logic there. In the sense,
yes, yeah.
I'm not saying he's wrong. I'm not saying I'm wrong. I'm right over here. I do not know. I do not know. So let us not, don't unnecessarily memorize things which are going to be controversial. Because when you introduce more controversy, that basically means you're introducing more assumption in your brain. And the more assumptions you have, the less fluidic, lesser freedom you can experience with respect to your thought. So you're making yourself more rigid if you have more assumptions. Anyway, coming back to the next part here. CCl3, CF3. Why is this the case?
Sir, F will pull the electrons from the carbon. So
effectively, you're going
carbon,
to be having normal electronegativity being the case here, correct?
yeah.
The fluorine is more electronegative than the chlorine, so it is pulling more.
Yes.
Cool. Next, how about this?
Oh, yeah, sorry. Yeah, yes.
What's happening here?
This one I wasn't sure about.
This one is an SO3H, correct? SO3H,
Yes,
now it is like this.
yeah.
Correct? The sulfur is going to be at least in a +5 oxidation state here. That makes it highly electron poor.
Yeah.
And highly electronegative. So its electronegativity ends up increasing here, and it is going to be doing a very good job of pulling. And more critically, it is attached to two sp2 oxygens. Very highly electronegative fellows. So you're familiar with how the sulfonic acid is extremely acidic, correct?
Yes, sir. Yeah.
That's because of the same reason. This particular oxygen is also electron deprived badly. So in this particular case, the sulfonic acid group is a fairly powerful electron withdrawing group. Cyano, for obvious reasons, C triple bond N, sp hybridized carbon attached to an sp nitrogen. Remember, sp nitrogen is more electronegative than an sp2 oxygen. So this is very powerful electronegative. NO2. All of these are the nitrogen fellows, standard nitrogen fellows. What is the problem with the NO2 here? NO2 is of course going to be what? Nitrogen with a +1, right?
Yeah.
So this is NO2. So of course it's nitrogen with +1. It is planar. Being planar has an advantage. The advantage is if there is water or some other solvent, it will stabilize this nitrogen +1 a little bit more, because the nitrogen can be surrounded by those water molecules a little bit more comfortably. So in this region and in this region, water molecules can approach it now. It will get more nicely stabilized if a solvent is available. Now, why is the NH3 plus better than the NR3 plus? That reason only. If I have an NR3 plus,
Repulsions between R groups.
yes, repulsions between R groups is going to be enormous, and the plus is something which is surrounded by fat fellows. Being
Yeah.
surrounded by fat fellows, other solvent molecules which can stabilize the nitrogen cannot approach.
Hmm.
So since they cannot approach, this is much worse off. Same
Or
goes,
the
yes,
bond length will increase, right?
no, that and all doesn't really matter.
The bond length increases, then electron
No,
will
no, no, no,
deprive.
no. Stop for a second. Stop for a second. Stop thinking bullshit here. What does bond length have to do with shit here? Where did you come up with bond length crap here? What's your logic for bond length?
I said more repulsions are there, so
So, so in this case here, who is the boss in those bonds?
nitrogen.
Ah, so you really think the boss in those bonds is going to give a shit about longer bonds? Who is the one who will suffer from the longer bond?
These
Yes,
are alkyl groups.
yes. So is the
Hmm.
nitrogen going to be affected by longer bonds in any way?
Slightly.
No. If there are longer bonds, it is beneficial for it. Right? That means the bond is going to be weaker. Which direction will the bond be weaker in? This nitrogen is one of the most electronegative. That's why it is highly minus I.
Hmm.
Correct?
Hmm.
So if it is highly minus I, where are those bonds going to be pretty much? They are in the goddamn vicinity of nitrogen only, those electron pairs. The other guys are like barely hanging on to each other and fighting with each other at the same time.
Hmm.
You understand the situation there?
Yes, sir. Yeah.
Nitrogen has nothing to play with in the bonds over there. It doesn't give a shit about those bonds.
Hmm.
So what you are trying to explain there is a completely conflicting understanding. Never ever go in that direction. See, there are going to be some types of, see, when you are learning things for the first time, it's like you are now literally going through a forest. All right. What am I doing over here? I am a guide who is basically not even me. Your school teacher is your actual guide. Your school teacher is your actual guide who is trying to guide you through this forest. When I say guide, he also gives you, what to say, tools for you to survive in the forest. But your school teacher is a trekking guide who has to show off that he knows the forest very well. So he has to take you to all the beautiful spots in the forest, which are going to be a pain in the ass to trek towards. You are going into the forest for the first time. Behave like a visitor for the first time. Stop trying to visit spots which are meant for professionals. In this particular case here, what you're asking is effectively something along those lines. And when you're trying to make up a logic, what you're trying to do is something which a professional should be doing. Someone who actually has walked this path and has made their own path, they can start doing that kind of a jump. Applying your intellect is only going to lead you down the wrong path here at this stage, because you do not have enough data. Applying your intellect here means behaving like a goddamn pro when you have no business behaving like a pro. Am I driving the point through here?
Yes, sir. Yeah.
So in this particular case here, stop. See, first learn the standard things first, because unfortunately there is no other way. In this case here, the true logic is not having to do anything with the bonds over there. The true logic has to do with how the nitrogen is stable and why is it unstable. The reason why it's unstable is because other fellows cannot approach it. These three fighting is like a pack of rabid dogs which are near a nitrogen and are fighting like crazy. The owner of the three dogs doesn't care because the three dogs are surrounding the owner, but nobody else can approach that owner now.
Hmm.
You understand the point over there? That is the real problem here. So the owner might be having 5 suitcases to carry and might need help, but nobody can go help.
Yeah.
Why? Because the rabid dogs around that owner are basically not allowing anybody else to approach. That is the true problem here. The nitrogen here is desperate for something to come and donate it electron density. It is having a positive charge here. It wants to get solvated and surrounded by molecules which are at least sharing their electron density with this guy. But nothing is allowed to approach this particular nitrogen here. Why? Because the three fat groups around it are making sure nothing can approach. That's the problem.
Hmm.
You're clear here?
Yes, sir. Yeah.
Okay, now let's go for the last fellow there, NF3 plus. What's the issue there? These are fat groups with 3 lone pairs each, and they are also screwing also with the nitrogen.
Yeah.
So effectively, this is steroids of the previous case.
Yeah.
Now,
Yeah.
next, which parts do you still have issues in? Any
Uh,
further? Yes.
Sir, when you're checking strength of plus A and minus A of different compounds,
Mhm.
I was like, we were given a priority list. Like you should follow that the distance should be greater than the number should be greater than the power of the group.
Again, avoid rules.
But it's working everywhere.
No, it's working in the questions you have seen.
Oh.
So give me the rule. Let's see what your rule is stating actually.
Distance should be given more priority than number of groups should be given more priority than the strength of the group.
So distance is more priority than number of groups. Number
Is
of
more
groups
priority than
more
strength.
priority than strength of each individual group.
Yes, sir.
That sounds like a reasonably good logic. And there will be very, very rare cases where this will fail. This is a very good set of logic. You can use this. But remember, there will always be boundary conditions.
Sir, what? Why is this correct? Like if you had like
Second, what is the logic which we just talked about? Remember the explanation I gave you? The visualization which I told you about just a while back?
yeah.
Imagine it in that sense. Things will become blunt. Right?
Wait a minute. It's kind of
No. Make it convincing for yourself. What does the rule basically tell you? If I have a deep depression right next to me, I'm going to feel it more.
yeah.
Correct?
Oh, and if you have multiple number of small, okay. If you have a very big one, but then how do you compare the last one? The
You
strength, like
think, you think. I told you the visualization. I'm not going to be helping you in every tiny bit of the case. You have an intellect which you have an ego over, right? Think.
some cases.
So the last one is you give priority to more number of deeper pits than one pit which is going to be slightly deeper.
But what about the distance?
Think. In
Okay.
this case, will distance be a factor? Should you consider distance? If distance is a factor, distance is the most important, na?
Yeah.
So in the case when you're comparing the second and third parameter, what should you do?
Oh, sorry. Yeah, correct. Yes, yes.
Stupid shitty bugger. I mean, you claim you understand mathematics properly, but you don't apply it in these cases.
Okay, I understood. Yeah.
What am I talking about from mathematics now?
This has greater weightage. Like if this
What
increase,
concept am I talking about from mathematics here?
logarithm,
No,
exponential.
No.
No? Oh,
I'm talking about partial differentiation.
I don't know.
Okay, you've learned differentiation.
Yes, sir.
So when you're having a function depending on two variables,
Hmm.
you want to study the dependence of the mathematical function on one of the variables. What do you
Yeah,
do?
that's what
You
I
keep
said.
the other guy a constant and you play with the first guy, right?
Yeah, that's what this is
That's
exponentially more.
basically what is called
That's
partial
what I meant.
differentiation.
Okay.
In this case, that's basically what we are doing over here. Effectively, when you want to play with the second and third variables and find which one is more important, you should keep the first variable a constant.
Yeah.
So you can compare two groups at equal distance from a particular location, which are slightly less depressing, less deeper than one group which is at same distance.
Yes, sir. Yeah.
You understand the idea here?
Yes, sir.
Next doubt you have, next concept you have an issue with?
1 second.
So your elder brother is visiting now then.
Yeah.
Visiting or he stays here with you?
No, he's visiting.
Visiting, okay. Where is he working?
He's not working anywhere yet.
Okay.
So,
Hmm.
sir, can you explain electromagnetic effect once?
What did you understand by it so far?
Well, like we were told that in the presence of a reagent, then it
So your
like
doubts basically stem from the fact that what does the entire statement really mean? Why that statement is that way?
yeah.
Okay, fair enough. So let's talk about a molecule. Okay, so
Yeah.
in a molecule, let's say we are going to be having different types of bonds. Okay, so when there are different types of bonds available, let's say that molecule is about to react. Then when a molecule is about to react, something has to happen during the reaction, correct?
Hmm.
What will usually happen during a reaction? Some bonds must break, some bonds must
Yes, exactly. Yeah.
break. So some bonds must break.
Yes, sir. Yeah.
So if some bonds must break, if I'm going to ask you to react and form a product, I want you to make a change in yourself and be a changed person tomorrow. What will you do?
Change the least affecting thing.
What is that?
Uh,
You'll break your leg?
yeah.
No.
Like,
You'll cut
no,
your
no,
hand.
no. Here, yeah. I was thinking here. Yeah.
You'll cut your nails. You'll paint your
Nails.
face. So the
Nails.
idea here is you will do the one which is going to be easiest for you to do,
Yes, sir.
or the easiest bond for you to break, you break that.
Okay, that's why.
So in a molecule where there is sigma bonds and pi bonds, pi
Hmm.
bonds are usually the weaker fellows every time.
Yeah.
So if the molecule is going to be reacting, it will usually react at the location where the pi bond is present, because that guy is the easiest to break.
Yeah. Yeah.
Okay. So far, you have understood that part now. Next thing, when it comes to pi bonds, what kind of a location is a center which is having a pi bond, a location which is having a pi bond? So if I have, say, a carbon-carbon pi bond in a molecule,
Hmm.
what type of a location is that in the molecule?
Outside the plane of the molecule. Like,
No, 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 no. You're not
mm,
understanding my question here. Imagine a building. Okay. My molecule itself is represented by a huge building. Okay.
hmm.
Now, in that building, what will the pi bonded location of the molecule look like or feel like?
restrict like
There will be restricted rotation,
yes, that's right. Yeah,
but there will be a lot of free electron density available.
free electrons. Yes,
Microwave,
yeah,
which is not that tightly held on over here.
yeah,
Correct.
yeah.
So effectively speaking, it is a location which is more tight. Restrictions are there, but there is a large amount of electron density floating around in a relatively loose manner. Correct. So effectively speaking, this is a location where there is a concentration of electron density in the molecule compared to the other locations.
Yes, sir. Yeah.
So what type of systems will be attracted to this place?
Electron deficient.
Good. So electron deficient fellows will be attracted to this guy here.
Yes, sir.
Now comes the next part of the question here. If I'm going to be having a pi center available, okay, what I'm going to be now having is I have now accepted, or rather I have now hopefully convinced you into understanding that the pi bonded location in a molecule is the one which is going to be targeted first. Why? Because that is the one which is easiest to break. First one. Next, when a pi bonded center is to be considered, in normal cases, the pi bonded center is a center of extra rich electron density. Normal conditions, like a C double bond C or a C triple bond C. So, what kind of a system is it going to be more strongly attracted towards? It will be attracted towards electron deficient systems. But that is not the case for all pi bonds. There are some pi bonds which will be attracted towards electron-rich species also. We'll talk about that in a bit. But when I have any pi clouded center, what happens in that particular case there is that particular pi cloud center is going to be something which is going to be susceptible to attack predominantly. When an attack happens on it, the pi cloud is something which is very easy to shift around. It is not that tightly bound. So it simply moves in the direction which suits the electron shift which is going to be happening. Let me make that point a little bit more clearer. So if I have, say, a C double bond C type of system available, okay, this is a center where there is going to be a pi cloud available, where originally it is like this. So effectively you have a sigma bond over here, and you'll have a pi cloud which is going to be floating above and below. Diagram is poor. So I'm just going to scrap the diagram completely. We'll go with the basics itself. So if I'm having a C double bond C available, then I'm going to be having an electrophile attacking it. An electrophile is something which is electron poor and is interested in extra electron density. So in that particular case, the pi cloud will shift towards the attacking electrophile so that that attack can happen more easily. Or you can think of it as, because the electrophile is coming, that particular pi cloud is shifting. You can think either way. You can think of it as electrophile is coming and hence the pi cloud is shifting to go meet it. Or you can think of it as, because the electrophile is going to be moving in that direction, the pi cloud is also moving in to facilitate that attack to happen in a better manner. Both ways are perfectly fine. Okay. So the idea is, you effectively have to simply apply physics over here. The pi cloud has to be attacked. So it will do what it can to favor the attack. Why should it be attacked? because that is the easiest place to target. No other reason.
Okay. Yeah.
In this particular case here, if a nucleophile targets it, now a nucleophile will never target something like this, but it will target it like this. If a carbon and an oxygen are present, this carbon will have a high delta plus.
Yeah, it wants to get positive.
So when a nucleophile is targeting this, now what will happen? The pike load will shift away from the attacking fellow. So this shift, where it is shifting towards the attacker, shift towards attacker, this is called plus electromeric effect. And in this case, shift away from attacker.
And see.
This is minus E effect. As simple as that. Nothing more, nothing less.
Okay.
You're clear with this?
Yes, sir. Clear.
Now, next. Next to.
That's about it.
That's about it. Seriously.
Yeah. Yeah.
Give me a second.
Yeah. Oh, sir.
Yes.
Yeah. Sir, in resonance, we were told that linear resonance will be given more priority than, it will be stronger than cross resonance. Like,
Okay.
why is that so? Like,
Give me the example you saw.
sir, 1 3 1 2 1 3 5 hextriene, yeah, hexa 1 3, yeah. Is it?
I'm guessing you saw something like this.
Yeah, something like that.
Hmm?
Yeah.
Were these the rough cases you saw?
Yes, sir. Yeah.
So, what do you understand by resonance?
Like,
How should you visualize it image-wise? So let's. You've discussed what is aromaticity already.
yes, sir.
Aromaticity is done for you so far.
Yeah, to an extent, yeah.
So your teacher has already discussed what is aromaticity.
Huh.
Okay, so explain what is aromaticity, what is resonance.
Sir, we didn't go much into depth about aromaticity. Like, I'm not sure too
Okay,
much about that.
okay. All right, let's go into resonance itself. So when it comes to resonance here, in this particular question which you have asked, there are many ways of looking at the answer for this. A very simple way of looking at the answer would be to just draw the resonating structures. Right. So when you're drawing the resonating structures, you will literally get more stable resonating structures for this compared to this. Why? Because in this here, you will end up having this location being the pain center more often. Do you understand what I mean by pain center? There has to be resonance now. It has to be this way or it has to be this way, correct?
Yeah.
So either this end and this end will be pain center, or it will be this particular ending and this particular ending which will be pain center. Correct? When I say
Yeah.
pain center, I mean something which has a charge.
Yeah. Hmm.
So the
Yes,
same
correct.
location technically ends up getting a charge every time. Right?
Yes, sir.
In this here, it will be shared by all of them nicely. Right?
Hmm. Yes.
So the pain center gets distributed equally well in all of these cases. That is basically the idea here. So in the linear thing there, the pain basically or the charges. When I say pain here, I mean the locations which are charged in the resonating structures. When you draw resonating structures, different carbons will take the charges, correct?
Hmm.
Among the charges, which charge is more stable? Minus is more stable than a plus. Because in a
Yes,
minus
sir.
there is octet, in a plus there is no octet.
Yeah.
Correct. So when you're drawing the resonating structures, there are pain centers created every time you draw a resonating structure. Pain
Yes, sir.
centers are those which are going to be having charges. So among those pain centers, if the same location is having the pain more number of times in the resonating structures, that is less stable.
Hmm.
You understand the idea here or
Yes, sir.
not?
Yeah.
You want another metaphor or you're clear with what we've talked about already?
I understood.
Okay. Now, let's look at another way of understanding resonance. I asked you about a visualization with respect to resonance, correct?
Yes, sir.
The best way to imagine or visualize resonance is like a flow of water,
Hmm.
which is rushing from different
Different parts. Okay.
tanks. Yes, sorry.
Nothing. Nothing.
Uh,
Nothing.
you were visualizing something just now.
No, no, nothing.
You're pointing something to your brother.
No, no, no. He's not
Then
here.
what did he mean by this? I'm curious because that symbol is something which
No,
did. Hmm.
flowing, I'm saying. Like water
Correct,
in
correct,
different
correct. That's
paths.
basically the exact thing which I'm looking at over here. That's why I was interested in what you showed that time because the flow is what is important over here. So the idea
Like
here
different
is
pathways.
so effectively you're going to be having different tanks present, and these tanks are connected by pipes,
Hmm. Hmm.
and water is flowing between these tanks.
Hmm.
The more stagnant the water is going to be, the less stable the system is going to be. The more the water is going to be constantly flowing, the better the stability of the system is.
Hmm.
In this case here, the water is of course going to be your analogy with respect to your electron flow here. So if I'm going to be having a molecule like this is going to be a long stream. So there is going to be lesser stoppage of the flow of electron density. It is like a clean, smooth flow. All right. So it's going to be a clean, smooth flow where the flow is only having two real problem areas. What are the two problem areas where the water or the flow will become stagnant? In this molecule,
Hmm.
what are the two areas where the flow of electron density will become stagnant? The two
In the
corners.
middle. Yeah. Oh, sorry.
The two corners predominantly. You will
Yeah.
also have these two middles also being small spots, but they're not going to be
Hmm.
that much.
Okay.
The two corners are going to be the real spots where the electron flow has to turn around. And it will obviously
Yes, sir.
be something which is going to be slowed down over there. So however fast the turning is going to be for the flow there, it is still going to be turning. So if it is turning at a depression, it is going to be slowing down. The more it slows down there, the more stagnant that particular region is, the less stable it is.
Hmm.
Density or the flow of electron density gets stagnated to some extent. When I say stagnated, it is slowing down. So you can either think of these locations where the carbons are present as either depressions in a field or as, what to say, hills in a field. Either way, when the flow of electron is going through there, it will slow down as it is going down and then coming up, or as it is going up and going down. You understand what I mean by that now?
Yes. Yeah.
I'm not sure whether I got through to you. Now, in this here, what's the problem here in this second structure here? In this second structure, the real problem is that there is a flow like this, and then there is a flow
It's like
like this.
interesting. Like yeah.
It is getting stuck over here predominantly.
Hmm. Okay.
That
Okay.
is going to be
Understood.
a much larger pain center, which is needlessly created.
Oh, okay. Okay.
That
Okay.
is the
Hmm.
reason why it is going to be a problem. That is what you are getting when you do resonating structure also.
Yes, sir.
When you
Yes.
draw the resonating structure, if the resonating structures are drawn following the rules properly, they will give you a clearer idea as to what your visualization tells you. Your
Yeah.
visualization is to help you build instinct towards it. What is instinct? Instinct is basically what you have visualized already. You plot the coordinates on that map and you think the next step is directly predictable. That is instinct. In this case here, you need to build the correct visualization so that your instinct with respect to these things are built up correctly.
Hmm.
If you build the
Okay.
wrong visualization, your instincts will not be built correctly. They will point you in the wrong direction there. So you understand how this particular thing works out over here? Is this clear properly?
Yes, sir.
Okay, next one.
Hmm.
Are there any topics to discuss at all? Because we have like another maybe 10-15 minutes max. So if there are any larger chunks, let me know. Otherwise, if you have only these kind of, what to say, small territories which we need to chart out more properly, we can continue with this itself.
Sir, like, what are the limitations for steric hindrance? Like, in which cases would, like, we learned about something called Sir effect.
Steric inhibition,
Uh,
resonance, again,
yeah, that thing.
unnecessary terms. Go
Yeah,
on. Hmm.
yeah. So, uh, due to this effect, like, the repulsion between the bulky groups cause the atom, like, a few, it to be coplanar, like, sorry, outside
See,
the plane.
calm down, calm down. So effectively, you have just started learning this for now. So you'll be learning this in a lot more detail when you are going to be learning benzene and its effects. So the idea here would have been something like this. You would have talked about, I'm guessing this guy,
Uh, yes.
in comparison with,
Yeah,
say, this fellow. Yes or
uh,
no?
no, not this one actually. No.
Which one did you discuss?
Sir, we didn't do like we did see like tertiary carbonism instead of
No, instead of a methyl,
huh.
nice fat fellow then.
No, instead of the COH, and then we put two methyls in the side.
Instead of the carboxylic acid, what do we have there?
We have a tertiary. We have a C plus and connected it to huh. Yeah,
Okay, effectively these are the two fellows compared.
yeah.
Okay, all right. So in this particular case here, the comparison was basically made with respect to stability of a carbocation.
Hmm. Yeah.
Okay, all right. First of all, I made gross errors over here. I'm surprised you didn't notice anything.
The carbon should not be there.
Hmm?
Only 2 carbons should be there. Yeah.
Yes.
So also one more doubt. I mean, after
Yeah.
that. So I tell now only.
Ask off.
Sir, there are 3 compounds given, and we are supposed to compare the bond lengths.
Three
So
compounds given. We are supposed to compare their
bond lengths.
bond lengths.
Given bond. I'll send the thing.
Yeah, send me the stuff, please. Okay. So let's quickly talk about this here. In this particular case here, the argument is that this particular methyl group here is doing no benefit. Correct?
Yeah.
Now, which one did your teacher tell you is more stable here?
The first one.
And why?
So why? Because the second one has resonance. Sorry, the first one has resonance, second one doesn't have resonance.
No. No. He gave you this guy and this guy comparison or what?
No. Just that. The CH3 is not there.
So the first one was the exact one I gave you. This is the one which is given.
Sir, the second compound had a CH3 to the left as well.
Sorry?
The second compound had a CH3 to the left of the thing as well.
Over here also there was another CH3.
Yeah.
Okay, now it is okay. Now it is acceptable then. Fair enough, okay.
Why
So
did you say that if only one was there?
if only one was there, then it would not have gone necessarily out of plane. It could have kicked the CH3 out of plane then.
Oh, I see.
The CH3 went out of plane. This guy will have resonance. And
Correct,
the CH3 will be a simple plus I group there.
Yeah.
It means this guy should be more stable than the other fellow.
Yes, sir. Yeah.
Right? You understand the point there?
Yes, sir. Yeah. Understood.
Since I have two CH3s, then the central fellow gets kicked out of plane. Depends on which guy gets kicked out of the plane actually. So
yes, sir.
steric inhibition of resonance is something you can do nothing about right now. And I sincerely suggest you do not waste your time regarding these kind of unnecessary effects. This is something which will show up once in a while in your exams. Wrong. It will not show up once in a while. It will show up every time in your exam. And what to say, maybe 1 or 2 questions per paper. My sincere recommendation there is, if you can recognize it, answer it. Do not search for it. Because when you are searching for steric inhibition of resonance, that means you are creating a blind spot for the remaining ones.
Okay. Yeah.
So avoid that as much as you can. Because if you end up searching only for steric inhibition of resonance, that means you are neglecting the obvious answer. That means you're training your brain.
This could also be at play, right?
No, listen fully. That means you're training your brain in the beginning itself to think about the wrong thing before you have trained it to think about the correct thing. So teach your brain to think about the obvious things first. Once you have gotten comfortable with that, then you do the steric inhibition of resonance. That steric inhibition of resonance is something which is meant for the players of the game who have played the game a little bit already. It is for them to pay attention to now, not for a newbie who is starting his grind. Collect the obvious ones which are going to be steric inhibition of resonance. Every paper you will find at least 1 or 2. Collect them, keep them collected. Make sure you don't feel bad or feel good about those particular questions, whether you get them correct or you get them wrong. Your job is now to make sure that you're collecting these questions and their answers, collecting the data. And when the time comes, when you have got enough data, you will automatically start answering them more carefully and more conservatively by yourself. So that should be the approach for steric inhibition of resonance. You will find enough examples of it. You will not find small number, you will find like 5 or 6 at least. So as of now, you have just started. There are a lot more available. Now, what other doubts do you have so far? Steric inhibition of resonance. What is your doubt with respect to it predominantly? Is it that you cannot recognize it,
I
or is it
no,
that you understand it?
I sent you a question, sir.
Okay.
Oh, sir, I forgot in the second compound, the bottom right one, there's C2H5 and CH3 also in the bottom, connected in like there.
Okay.
Yeah.
That is in this bottom fellow here. You're saying there is going to be one more
C
CH here.
C2 no C2H5 there. I mean, doesn't really matter, I guess.
ठीक है हाँ. Okay. All right. What is asked here?
A compare between lengths ABC.
ABC. So in this case here, you'll have full-fledged resonance, obviously. So
Yes.
here the bond order is going to be definitely between 1 and 2. Right? So it's going to be quite good over there. It is not going to be a problem at all. So good resonance. Here, it's a little tricky. So there is no rotation possible here and no pi bond possible, which basically means no resonance. So this is bond order 1 fixed. And obviously this bond is going to be shorter than B. C, on the other hand, if I have to compare it here,
So C
I would
also
say
doesn't have
C
free
is going
rotation,
to
right?
be little bit shorter than what to say A. So a little bit longer than A, but less than B. So I put it as A less than C less than B. Not sure about C though, because C has some problems there. It could be an interesting type of structure. What's the answer
Sir, but
given?
then shouldn't answer given was C greater than sorry B greater than A greater than C.
B
C and A are replaced.
A greater than C, yeah.
Yes, sir.
So you're
Sir, but
saying C
then
is shorter.
yes, sir, but then in B and C, both of them, like it will be single bond equal number of times, right?
No,
Bond order should be same,
no,
no?
no, 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 no. The reason why I did not want to comment on C is because you are going to be having a possibility of having a resonance,
On both
and you are
the
going to be having a possibility of having no resonance also. I did not know whether to comment on it and say it is going to be aromatic as a system or anti-aromatic as a system.
so
Because as
there's
of
no
now,
free.
it is not about free rotation. It is about whether this carbon here is going to be acting as a problem one or acting as something which can basically rotate comfortably. As you put it across, whether I can shift a pi bond in that location or not. So if the pi bond shifting is allowed here, then this system will be highly stable. In that case, C less than A less than B makes sense. If the pi bond shifting is not allowed, then in that case, these two will have repulsions with respect to each other, which is going to be similar to an anti-aromatic type of setup, but it is still going to be brought closer because of this carbon. If it is still brought closer, the C should be shorter than B for sure. Because in Bombay here, there are big fat groups, which will make sure these two rings are far apart.
Yeah.
Here, the groups are helping the two rings come closer. That's why I went with A less than C less than B. I knew for sure A was less than B. I didn't know where C would rank. But I knew C was less than B.
Sir, what is the doubt with respect to C? Because why is there confusion whether it will have resonance or not?
My conclusion is based on the fact that if there is no resonance, what do I mean by there is no resonance there? That means that this particular thing here is forcing this carbon-carbon bond to only be a single bond.
Yeah.
That is, there is a ring closure here, na? That might
Yeah.
make these two things to be in such a way that this carbon-carbon bond between them can never be a double bond. If it can never be a double bond, there will be no resonance between the rings. Right? That means this will be one ring, this will be one ring of electron density. Both are very close to each other, but are now not connected. Right? So if they are not connected, there will be repulsions between them, which will make it unstable. So even in that case, this carbon, the fellow over here, I assume this fellow will pull the two rings together and keep them close enough. Don't try to
Hello?
I am putting a filter in my brain right now to see every possible way in which I can see that. That's all. I'm not doing something extraordinary here. I am just putting a simple filter and looking at it from every way possible. And in every way possible, it looks like both are possible. But it is obvious that A is going to be less than B.
Yeah,
And
that
it
is.
is obvious that C has to be either over here or over here. It cannot be above B. Those are the conclusions we can definitely make.
Yeah.
Next. You understood what you wanted here?
Yes, sir, I understood.
Next one.
One second.
Are you able to maintain your physics performances at a decent level now properly?
Yes, sir, somewhat.
Somewhat.
Yeah.
But as of now, it is coming at the cost of not solving enough questions in chemistry.
Yeah.
I still haven't asked you how many you solved.
Yeah.
And the way you are asking questions, I think your number is around 75.
Oh, no.
How much?
It's like cross 100.
Okay, fair enough. But that's in 2 weeks, right? 1.5 plus weeks.
Kind of, yeah.
Okay. Let's continue. Let's continue. Next.
One second. Sir, what is cross conjugation? Like conjugation on both sides? Like,
No, this is cross conjugation.
yeah, that's what I meant. Okay. Then, sir, we learned about something called ortho effect. Can you explain that? Yeah.
It is similar to your static inhibition of resonance.
Sir, but then,
The idea there is, why is it called ortho effect in the first place? It goes like this. Whenever there were substituents present on a benzene ring, normal common sense based on inductive effect, resonance, all of those suggest a particular trend. Okay. When normal inductive effect, resonance, everything suggests a particular trend. But in all the cases which are going to be meta or para, this normal common logic which you can apply applies, works properly. But in those cases where there is a group present in the ortho position, whatever we expect, opposite of it is happening. In the beginning, when scientists did not know what was really happening, they gave it a common name, calling it ortho effect. Like they just grouped all of the shit together and called it ortho effect. When you ended up having, what to say, scientists breaking these observations down and explaining them away individually. Different types of things got different types of logic. Some of them got logic as steric inhibition of resonance. Some of them got the logic as intramolecular hydrogen bonding is happening. Ortho location na intra hydrogen bonding ke liye bhi it is good na, immediate neighboring location. Some of them got other kinds of logic. In the beginning, when they did not know what was the correct excuse, when they clubbed all of the excuses together as ortho mein jo bhi hai uska bhaad mein ja. And weird shit is happening, let's call it all together as ortho effect. That is what ortho effect is. So do you have clarity here as to what I mean by ortho effect? In some cases, even now, you will still have no logical reason working out properly. In those cases where we cannot give a proper reason, what is our be all end all solution for it? वहाँ पे ortho effect हो रहा है. That's the basic goal. You understand the idea here? Okay. In some cases, the ortho effect is explainable properly by either steric inhibition of resonance, meaning one of the groups is kicking the other guy out of plane, some resonance is basically not happening, or by intramolecular hydrogen bonding usually. Other than these two, in some cases, even these two explanations will not work, but the ortho will still be doing something funny. In that case, we directly call it as ortho effect. Still. Now tell me which example you are asking about.
Sir, we were given that irrespective of the nature of the group, that this ortho substituted benzenoic acid will be more stable than the meta and para substituted one. How can we guarantee?
More stable or more acidic?
More stable.
Repeat. Ortho.
Irrespective of nature of group, ortho substituted benzenoic acid is more stable than
meta
and para.
Have they really given you more stable?
Maybe I wrote it wrong. But...
Is it the acid they're telling or the ion they are talking about?
Acid.
Yeah, that statement is wrong. It's supposed to be the acid is more acidic than...
No, ion. It's an ion.
If it is an ion, then that is correct. The anion formed is more stable, which basically means the parent acid is a stronger acid.
Okay, yes, yeah.
You want ionic equilibrium, na?
Yes, more stable one.
Yeah. So that is supposed to be the logical. That's why I was asking whether it is given as the anion or the acid over there.
It was
so
ion.
If given as anion, it is more stable. If it is given as acid, it should be given as more acidic. So, what's the issue here then?
So no matter what group you put there, it'll still
no. You're oversimplifying shit here. What did I just explain to you here?
Only a few cases where we don't know what's happening.
Listen to my question again clearly. What did I explain to you about ortho effect just a while back? What was the real crux of what I just told you? The crux of what I told you is, it is bullshit.
Okay.
That in the beginning, it started off as a bullshit effect, which they didn't understand what they were doing. So they came up with a lot of unnecessary, crappy assumptions at that time. None of which have any substance in terms of logic. Once they started understanding the effect a little bit more clearly, how did they start understanding the effect a little bit more clearly? They broke it down into pieces. They stopped seeing it as ortho group in carboxylic acid. No. Every individual ortho group in a carboxylic acid type of situation will have its own unique case.
Okay.
Do not attach a blanket case and say सबके लिए ऐसा है. वो ही यहाँ पे गलती है.
Okay.
So what is the point you should be taking about this particular information which you gave me? That is a piece of data for you. That is all. Which has been confirmed by your school teacher with great pains over the years. What should you take as learning from there? The learning you should take is, okay, in these cases, this is how it's supposed to be logically itself, and it is still following. Good. In these cases, I expect that the logic is supposed to be this, but it is going against my logic. That means in these cases, ortho effect is actually happening. What does ortho effect is happening mean? It means reverse shit is happening. Unexpected is happening. You understand what I'm trying to explain to you here?
Yes, sir.
So if I have, say, fluorobenzoic acid, if I have a compound like this, this guy is more acidic than benzoic acid, not because of ortho effect, but because that nitro is a minus R group. See?
Minus R.
Minus R and minus I. Correct?
Minus I.
So this is more acidic than benzoic acid, not because of ortho effect. It is more acidic because it's more acidic. Basic logic tells me it's more acidic.
Okay, understood.
Ortho effect playing a role there?
No.
No, it is not playing a role.
Okay.
You understand what I'm trying to tell you here with respect to your statement here?
Yes, sir.
Your statement is bogus.
Okay.
The way you are using the statement is wrong.
Yeah.
The statement is bogus in the way you stated it and in the way you are thinking of using it. If you thought of ortho effect as opposite of whatever should happen, and you think in this case ortho effect should happen, what will that tell you then? It should be opposite. That means it's less acidic.
Yeah.
Right? Is that what's happening?
Yeah.
No. That's not what's happening. It is more acidic than benzoic acid.
Yeah.
So
there's
the
a
idea
reasoning
here
for it.
is your statement over there has to be very carefully tailored and understood. If you remember the statement as all ortho-substituted benzoic acids are more acidic than benzoic acid. Good. If you remember the statement as all ortho-substituted benzoate ions are more stable. Good. If you take the statement as all ortho-substituted benzoic acids show ortho effect, and you remember it like that, you're fucked up.
Okay, yeah. Understood.
You understand the key difference in the way to treat that statement over there?
Yes, sir. Yeah.
So your teacher has been very clever. Teachers always are very clever. When they are giving you compromising or controversial statements which can go this way or that way, they will choose the safest way out. But if you make the mistake in your assumption there, it is not the teacher's fault. It is your assumption which is wrong.
Okay, it's not due to ortho effect, but other reasons.
Yes.
Yeah. Okay, that's all. Yeah.
Am I clear with what I'm trying to explain over here?
Yes, sir. Yeah, I got it.
So the statement is correct as a standalone statement that all ortho-substituted benzoic acids are more acidic. Correct. But ortho effect doesn't necessarily have to do with it.
Okay. Yeah.
In some cases, it may be because of ortho effect. Wherever it is going opposite to the trend, the expectation is going opposite to the answer which has been given here. In those cases, it is because of ortho effect. Like if I have a methyl group in the neighboring ortho location, if I have this guy, or if I have this guy, in these two cases here, I expect both of these groups to be electron donators to the ring, correct?
Yes,
Methyl group and OH are electron donators to the ring. net
Yes,
electron
sir.
donators. That means they are going to be increasing electron density. That means they should be making it less acidic. But they are
Yeah.
also substituted, so I know they should be more acidic. You
Oh,
understand or not?
yes, sir. Yes, yes, yes.
That
Correct.
is my
Yeah.
logic over here tells me the methyl substituted fellow and the OH substituted fellow should technically be less acidic. Why? Because this is plus I and plus R. And this is plus R and minus I. Plus R dominating, correct? You have
Yes,
learned
sir.
this or not?
Plus R, I have not learned, but
Plus R na plus resonance.
yeah,
It is
I
dominating
think
with.
understood.
You have not yet learned that. Okay, fair enough. You'll be
No.
learning that soon, I suppose. Okay. So the idea here is this CH3 is an electron donator. The OH is also a net electron donator. But
Hmm.
both of these guys are more acidic. Why are they more acidic? Because of ortho effect.
Hmm.
Now, in these two cases, the ortho effect is explainable also. How so? Here you can say the COOH goes out of the plane.
Hmm.
Implies
Yeah.
resonance with
Not
rate
possible.
increases. Okay?
Oh, yes.
That is going to be one way of explaining this. It is ortho effect, but explained ortho effect. In this case also, it is explained ortho effect, intra-hydrogen bonding.
Hmm. Sir, compared to meta and para, then this will only have greater acidity.
Ortho effect has nothing to do with comparing with meta and para.
But then generally
Do
we
not
can't
do
say
that
no.
comparison. Do
Okay.
not. Do not. Ortho effect has nothing to do with comparing between the meta and para substitutions. Ortho
Hmm.
effect has to do in comparing with the original, without the substitute. Am I
Okay.
clear what I'm trying to
Yes, sir.
explain over here?
Yes, sir.
Do not make unnecessary extra attachments.
Yeah.
It is going to be correct. Your brain seems to have recognized that there are some connections there. Avoid making any assumptions about it. Notice the connections, let it go. If you find it repeating in exams more often than not, it will be a good connection for you to remember later. I have not seen any connections regarding that. That doesn't mean I have seen all the connections. So, anything else for today? Or shall we wind up?
That's it, sir. Nothing else.
You still have some more than the way your voice is sounding.
No, that's it. We didn't do anything else. That's
So, it looks like your organic is definitely progressing in a shaky way only. Because you're getting jatkas here and there. Good. My prescription still stands. No change in that. If you've gotten your numbers to only 100, 150, you will have to up it because it's like 1.5, 2 weeks worth of workload. 100, 150 is not enough. You want to see meaningful progress, you will need to give 3 weeks with at least 100 to 150 questions per week continuously. Then you will start seeing serious improvement. When I say serious improvement, I am saying you'll see like proper, remarkable, proper progress. 3 weeks though, you will have to continuously 3 weeks or 3 exams, 100 to 150 questions per exam. Practice that much for 3, you'll be there, close enough. Because what I'm recognizing is you are quite sharp at recognizing the problems which you are facing. Most of the questions you're asking me are questions with relative substance. They're not really flaky bullshit. So that means you are recognizing the issues which you are facing quite quickly. You are improving fast. So, I would recommend like 3 weeks, maximum a month. If you can pull off like say 300, 400 questions in a month, or maybe even 500 questions in a month, you should reach very close to where your position was with respect to chemistry earlier. But it has to be continuous weeks. It cannot be with a break. The moment you take a break in between, you have to restart the shit again.
I think
Hmm.
we only have like 2 more exams for the year, I guess.
For the
And then we
entire
have IP. Yeah, and then we have IP preparations.
fuck.
Yeah.
Okay. Okay. Jeez. Unfortunately, in tight shit over here, then because of IPA here.
And
In
chemistry
Chennai,
were very behind.
it used to be like the best time for Fiji kids. Because Chennai, the kids used to be in CBSE when I used to be in Fiji there. So
Mm.
CBSE, they only have to prepare for 12th.
Oh.
So, but they have half yearly exams, they have those kind of exams happening. Here, you don't do that shit at all, nah? You
No, we
don't
have
prepare
half
for
yearly.
school. You prepare
We
for
have half
school?
yearly. No. We just have half yearly.
Yours is not an integrated program, no? Yours is like Fiji run shit completely.
Ah, yeah. I mean, we have, yeah,
Fiji
state
runs
board.
like that thing, right? Officially, they
Yeah.
have some dummy shit over here. In Chennai, it's not dummy shit. It's like a proper integrated with like a big school. You know,
Oh.
Maharshi Vidya Mandir here, I think, right?
Yes, sir. Yeah.
That type they used to have tie up over there in Chennai with them. So
Oh.
that is like a proper integrated program which is with the tie up with the school. So the kids used to have like other subjects during the day. You have other subjects also or no?
Only Sanskrit and English.
And you have that daily?
No, only twice a week.
Twice a week. Also, they are having that also over here. Okay. So this is like Fiji World School, I believe. What is it called?
No, World School has more. I think they have like almost daily, I think, language classes.
What is your school called?
Junior college.
Fiji
Fiji
Junior
Junior
College.
College. Yeah.
Oh, okay. It's not got some other name then.
No.
Okay, all right. Okay, all right. See you then. Anything else to ask? Anything else
No,
to
sir.
discuss?
No.
My prescription still stands. I will be asking you more about how many you have done next time again.
Okay, sir.
By this Sunday, in this week, how many have you solved for the current exam? Today
Sir,
is like
we current examining next week's exam.
whenever you're coming away, Monday exam happens here.
I don't think we'll have an exam this Monday.
Okay, so you owe me like 250 questions before that next week exam then.
Okay.
At least 250 to 300.
Okay.
How many is your count at as of now?
I think 120 is something around that.
In the past 2 days?
Oh, no, not past 2 days. Total.
Oh no, I'm not interested in total. I want count resets after every exam. This is
Oh.
with the resetted count for the current exam. The current exam is 2 weeks worth, na? In
Ah.
2 weeks worth, I want at least 250 questions. So from yesterday and today, how many have you solved?
I think approximately 50, I guess. 50, 40.
50.
I think 40, I guess.
Oh, you are actually enjoying solving questions now to an extent now then. So you're solving easy questions. Good.
So I was doing isomerism.
Oh, okay. So you're enjoying for some other reasons. Okay, huh? Okay, all right, huh? Fair enough.
Yeah.
Which book are you solving from now?
Sir, my teacher sent some book. I'm not sure.
What's the name?
1 second. It's
Mhm.
called Organic Chemistry 1 by Rajesh Agarwal. I'll send that one cover.
Send the thing to me. Is it comfortable enough where you're able to solve the questions easily enough?
Yes, sir. Yeah, it's fine. Yeah.
You're not finding it like that
No. It's easier than that. Yeah.
Akshay something, yeah, whatever that thing was, huh?
Pearson thing.
ये तो याद तो नहीं है चलो हाँ छोड़ो हाँ okay I think I have to shut up as well. I'll see you coming Sunday. Bye bye.
Yes, sir. Thank you, sir.
Good
I
night.
sent the book, sir.
Give me the book
Yeah.
please.
Good night, sir.
Good night dude.